So this is the PHS Poly Pure Science paper. I'll be going through question 5 and question 6 over here. So question 5 is your standard temperature thermometer kind of questions. Down here you can see that although it is not printed very clearly, it is digital. That means it has to do something with voltage. It has to do something with resistance maybe. So down here they are asking you what is the thermometric property. So refer to your textbook, there's a table giving you 4 unique thermometric property. You need to memorize how it is phrased. So down here we will accept either you talk about the change in EMF or you can talk about the change in resistance. So both of these thermometric property is accepted. So I will not write here because frankly I don't really remember it. But it is in your textbook, okay? It's in a table, okay? Refer to the chapter on temperature and thermometers. Two advantage of your digital thermometer. Now, because it is digital, it will definitely be very responsive. You can also, okay, by the way, since we are doing revision, when they are talking about advantage, right, there are a few areas that you can comment on. So number one is what I have covered, responsiveness. The other thing that you can comment on is sensitivity. Now for sensitivity, you are talking about the same temperature change. So for example, for a 1 degree C change, if thermometer A give me a 1 meter change of height versus thermometer B which give me 1 cm change of height, then I would say that thermometer A will be much more sensitive. So sensitivity is about the amount of change, right, per 1 degree C change of temperature. Responsiveness is about the time taken for the change to happen. Okay. There are other things like cost. So for this case, the cost not really obvious because actually mercury thermometer is also quite cheap. You can also talk about availability. Okay, I don't know how to spell, but availability. So both are as available as possible. The other one you can talk about is your range. So most mercury thermometer is limited by range because mercury can freeze, mercury can boil, similarly to your alcohol thermometer. So for digital thermometer, the range will definitely be larger lah. But in this case, because the question says that it is for our body temperature, so actually the range will be limited as it is just for normal use. Okay, but if you are talking about thermocouple, you are talking about other digital thermometer, then definitely they will have a wider range than typical mercury or alcohol thermometer. So responsiveness, sensitivity, cost, range, availability, size. Size is also important for thermometer because you need to insert that thermometer into the sample. So if you have like a big thermometer, then you cannot measure temperature of a small area, a small small object. Okay. What else? You can also comment on the safety. So safety is kind of new. So down here I give you an example of how to comment on safety. So for liquid in glass thermometer, if you break it, then there will be spillage, and if it is a mercury thermometer, it will be toxic. So as you can see, our lab, right, we started off with mercury thermometer, but after one incident that has happened, we decided not to give you mercury thermometer. So now in our lab, everything is alcohol thermometer. So as long as you make sense, we will give you the mark. So we accept responsiveness. Unfortunately, sensitivity, we can't give it to you because there's no data to give you to help you make a conclusion. Similarly for cost, we don't have enough data to help you. Range, unfortunately, this one is oral thermometer, so they won't give you like a large difference in range. So size also not much difference, so that's why safety will be the other good advantage. Okay, for part C, they try to use this normal body thermometer to measure something at 80 degrees C. So I don't think if your body temperature reaches 80 degrees C, there's still a need for this thermometer. I think a coffin will be more suitable. So why is this thermometer not suitable for measuring 80 degrees C? Because it is just beyond its manufacturing intent. Yeah, no one will design a body thermometer to measure 80 degrees C. By then the person will be on fire or simply dead, so you don't need the thermometer. Yeah, so that will be your question 5. Okay, for question 6 is your typical wave question, and this wave question involves the L wave, which is sound wave. Okay, so here 6.1, you are given a photograph. Because why do I say photograph? Because it's frozen in time. So this entire picture about dots is actually t equals to 0 seconds. It's a snapshot at time equals to 0. Then it says that your particle P actually vibrate from X to Y. So just imagine that this is a pendulum, and basically this pendulum is oscillating between X and Y. So meaning that this will be your equilibrium position. I use E, maybe I use the red color. So therefore the maximum displacement will be given by this. This will be your amplitude. Okay. So in part A, you are supposed to describe what happened between adjacent particle. If you do not know what is adjacent particle, it means the particle next to you. Okay, just next to the other particle. As the wave move through the medium, so as you know, your particle P, right, will just keep on vibrating left, right, left, right, left, right. So basically this is the adjacent distance that the question is asking you, right? This is adjacent distance. So as P is moving like here, this particle will also be moving, right, left and right, and they will move in a way to form compression and refraction. So just give a general statement is 2 line and 1 mark. So don't give a too complicated or too detailed description. Just give a very simple one. So here I say that this distance will actually drop to a minimum, and then it will increase to a maximum. So I don't even bother to say that the value and all that. Okay, and I will say that this change will continue until the particles stop an oscillation. Now why do I put this line in? Because I actually want to find an opportunity to define it as an oscillation. Okay, I'm not sure whether the pink part is absolutely necessary, but I think that 1 mark mainly is for the yellow part. Okay, so for part B, I'm supposed to label the distance of one wavelength by labeling the particle. So one wavelength, right, is either compression to refraction and compression. If not, refraction to compression to refraction. So in this case, I can see that down here, these two are actually my center of compression. So therefore, I know that this highlighted blue will be my wavelength, and so I highlighted Q over here and Q over here. So I will answer B that way. So similarly, if you do not like to locate Q there, you can also do like here is Q, then here is Q. It's fine. Okay, you can even say that this is Q as well. You can also say that this is Q as well. It is fine. Yeah. For part C, be very careful. I do not know why PHS like to play around with you in terms of the unit. This is in mm, not meter. Now they also rephrase, instead of telling you that this is the period, they actually rephrase it as time equals to 3 is the time taken for the particle to come back to the original position. So similarly, like your pendulum, right? If let's say I have a pendulum, what is one period? One period will be the time taken for the pendulum to move from its original position away and then back to its original position. So because of that, actually the period is phrased this way. So period is 3 seconds. So amplitude, I have already answered you at the beginning. Part 2, like I have explained, the 3 seconds is the period, so you can use F equals to 1 over T. So there's a formula like that to find the frequency. Remember 2SF. Then after that, to find the speed, V equals F lambda 2SF. Okay, so it is quite straightforward.